So here what we're going to look at is adding and subtracting rational expressions. And it's really just like adding and subtracting fractions of integers in that you have to have a common denominator, meaning the denominators have to be the same. And if they're not the same, then you have to obtain a common denominator. And once you do, you just add the numerators. Now, which common denominator do you get? I mean, there really is theoretically more than one choice, but the most convenient one is the LCD, the least common denominator. And I wrote out over here what that is. Again, it's the smallest, it's the denominator, it's the polynomial of smallest degree that contains each denominator as a factor. I did write out a procedure for obtaining it. You factor each of the denominators completely. Then what you do is you have to list each different irreducible factor once. When I say irreducible, I mean something that you can't factor down. You can't factor any further. So something like x plus or minus a number b would be irreducible. Or x squared plus b squared, where b is a number, that would be irreducible. You get the largest exponent, and you raise each factor to the largest exponent, and then you multiply them all together. You'll see what I mean when we do some examples. So for instance, let's first look at this one. I mean, this one's a little bit easier because the denominators, as you can see, are already factored. Okay, so what are the irreducible factors? Well, let's see. So let's list them. So I'm going to write out this. I made a little table, as you can see. I guess that's okay for now. Irreducible factors. So as you can see, we have x minus 1. And we're listing each factor only once. We have x plus 2, as you can see as well. We also have x. Now, even though we have x minus 1 squared, we don't list x minus 1 again. Okay, now we're going to pick the greatest exponent, the greatest or the largest exponent. Okay, so bear with me. I don't have as much room as I hope, but that's okay. So really, you can see now that for x minus 1, we have x minus 1 to the first here, but we also have it to the second. So because of that, we're going to have the biggest exponent as 2. For x plus 2, there's only one exponent, 1, and for x, there's only one exponent, 1. So the LCD then is going to be, this, x minus 1 squared times x plus 2 to the first. When you raise something to the first power, you really don't have to write the exponent, times x. That is our LCD for this pair here. Okay, so that's one example. Okay, so here's another one. Let's now find the LCD for this pair. Now, the second denominator is already factored, so that's good. But we have to factor the first one. So we have x to the 4th plus 3x cubed minus 4x squared. There we go. So this is what we have, okay? And now notice the smallest power of x is x squared, so we can factor that out. Now the question is, what's left over? Well, we're going to have here x squared. Next, we're going to have plus 3 times x. Then we're going to have minus 4. And now, this trinomial here, we can factor that further. Namely, we want two numbers whose product is -4 the sum has to be 3. Well, what two numbers are going to do that? 4 and -1. So we get x squared times x squared, excuse me, not x squared, times x plus 4 times x minus 1. So that is what we end up with. And again, the second denominator is already factored. Okay, so what are the irreducible factors here? The distinct ones, that is. What's nice is in this table, it's already written out the words. So we have x, as you can see. We have, what else do we have? We have x minus 1. Again, this is from the first denominator. Then we have x plus 6. All right. Now, from the second denominator, what we just factored, we have x already. We don't have x plus 4, so let's add it to our so-called list. We also have x minus 1 already. And now we need their biggest exponent. So for x, the biggest exponent is 2. And just to clarify, here we have x, right, to the first. So the exponent here is 1, whereas here it's 2. So we get this. For x minus 1, right, the exponent here is 1, but here it's 3. So the bigger exponent is 3. For x plus 6, there's only one exponent, namely just 1. And for x plus 4, same thing. The only exponent is 1. So in this case, the LCD is going to be this. We're going to have x squared times x minus 1 cubed times x plus 6 times x plus 4. And that is our LCD. So in other words, if we were to add or subtract these two rational expressions, this would be our common denominator. This is the common denominator we would use. Okay, so now that we have some idea as to how to get the LCD, we're going to use it in order to add and subtract rational expressions. And it's really just like what you do when you're dealing with fractions of integers. Once you know what the common denominator should be, you have to manipulate the denominator, right? And whatever you do, and whatever you multiply the bottom by, you have to multiply the numerator by as well. That's what I'm trying to say over here. So just like with fractions of integers, if you multiply the denominator by something, you must multiply the numerator by the same thing. And that is what we're going to do in this example. So here we have x minus 1, right? That's our irreducible factor from the first fraction. And the only exponent of it is 1. From the second denominator, we have x plus 2. And the only exponent is 1. So the LCD here is going to be just x minus 1 to the first. But again, if the exponent is 1, we don't have to write it, times x plus 2, like so. So that's our LCD. Okay? So now we need the denominators to equal to the LCD. Okay, so let's take the first fraction. We have x over x minus 1. We're going to multiply the bottom by x plus 2, as you can see. But remember, whatever you do to the bottom, you have to do to the top, like so. So that's what we get here. Now you could distribute the numerator if you want to. Let's just leave it like this for now. For the second fraction, we have 3x minus 2 over x plus 2. But again, we want the denominator to be x plus 2 times x minus 1. Remember, you can multiply in any order you want. So we have to multiply the numerator by x minus 1 as well, like so. So now that we have a common denominator, what we would do now is just add them. And of course, I'm running out of room. So now we're ready to add. Okay, so now we add these, and what do we get? Well, since the denominators are the same, we just combine numerators. So we have x times x plus 2 plus 3 times x minus 2 times x minus 1. This is all divided by x minus 1 times x plus 2. That's good. Okay, now we have to combine the numerator bit, so let's do that. So distributing the first product, we get x squared plus 2x. And the second one, by foiling, looks like we get 3x squared. Let's see, minus 3x minus 2x plus 2. And this is all divided by x minus 1 times x plus 2. So in the numerator, of course, we can combine like terms. So let's do that. So we have 4x squared minus 3x plus 2, all divided by x minus 1 times x plus 2. Okay, that's good. Okay, so that's what we get as our answer. Now, could we simplify this? Well, you could try to factor the numerator, but remember, if x minus 1 is a factor of the numerator, exactly when, if you replace x by 1, you get 0. So if we do 4 times 1 squared minus 3 times 1 plus 2, well, let's see. We have 4 minus 3 plus 2, which looks like is equal to 3, which is not 0. So x minus 1 is not a factor of the numerator. So I'm using a fact from an earlier video. Let's also check with x plus 2. Well, if we do 4 times negative 2 squared minus 3 times negative 2 plus 2, so that turns out to be, let's see, that's 16, because that's 4 times 4, plus 6 plus 2. So what is that? That's going to be 22, 24, it looks like. It's not 0, so because of that, x minus 2 is not a factor of the numerator. And from the first calculation here, x minus 1 is not a factor of the numerator. So because of that, this is already simplified. So I'm actually using a fact from earlier. Namely, we have x minus a. This is a factor of some polynomial. This is a factor of it exactly when p maps a to 0. That's all I'm using here.